Hello class. Today we'll be looking at a problem which you can find in physics or additional maths, mechanics in additional maths. Yes, so I think I should drop this before we go on. If you're having problem in physics, your problem can be traced to mathematics. And if you're having problem in mathematics, your problem can be traced to English language, when I was having difficulties in mathematics, the math teacher that I met that changed the course of my story or events in life in mathematics made me to understand that English language was my problem. And by the time I began to look at it critically, I improved drastically in mathematics, you understand, because of that. And for me, because of teaching this over the years, I've come to realize that the problem that most people have in physics can be traced to mathematics and English language. And physics is not just more of mathematics, which involves English. Physics is also quantitative reasoning. So it's very important that you know this. I think with this, you can go from a C student to an A, not just being an A, but the best overall in your class, in your school. Yes, it's very important that we know that. So looking at this problem, a body of mass 40 kg is placed on a rough. Hey, let's that underline that word rough. Rough there. It's an English word that must be translated to mathematical terms in solving this problem. Inclined plane, which makes an angle of 30 degrees with the horizontal. So this is my horizontal, and then he's making an angle of 30. Angle is where two lines meet. So this is my inclined plane. This is my 30. So with this, with the horizontal, so let me place that mass. Let me call this that mass 40 kg. You know, the center of gravity should be here. So the weight is acting downward here. And you and I know that Newton's third law of motion says that for every action there is an equal and opposite reaction. So for the weight to be acting downwards, there must be an upward force that is equal but in opposite direction. So this is that upward force, and we call it R, which is the normal reaction. So I can call this. So because this is on an inclined plane that's at an angle of 30 degrees, we need to resolve this force vertically and horizontally. So if we do so, we resolve this vertically and horizontally, this angle. Here is that 30 degrees. So you can see that we have done this. This is 40, your 40 kg, your mass of 40 kg. Now let's take this, and the way I always try to solve the problem is to go as it is written. For instance, this is a sentence. This is one sentence. So I try to represent that. When you are doing physics, you must learn to represent whatever you are told into diagram. Putting that in diagram helps you to solve the problem. You already have way to solving the problem when you draw your diagrams accurately according to what you are told. So since I'm told that it's a rough, it's a rough inclined plane, I should know that there must be friction here or here, depending on the next story. I will know where to place the frictional force, whether it will be here or here. Now, if a force of 420 Newton is applied upward, parallel to the plane. So if it is applied upward, so that force, this is the force, 420 Newton applied upward. So if there is a force applied in this direction, that means there must be the friction. Friction we know opposes motion, and friction is between two surfaces. So we should have that frictional force here, because it's a rough. But if it's a smooth surface, then there will be no friction. That means that friction is equal to 0. Having said that, the next thing we need to do is to resolve this. Like what I said initially, we can see here that according to Newton's third law of motion, and even according to when we do couple, we talk about the upward force is equal to the downward force. We can see here, find the maximum frictional force that will keep the body in equilibrium. So for this body to be in equilibrium, that means that R minus W1 is equal to 0, or we say that R is equal to W1. So resolving this first, going to maths, trying to resolve this. This is a right angle triangle, so we can apply our trig ratio. Using the knowledge of trig ratio in mathematics, we could see here that W1 over mg is equal to what? Is equal to cos theta. Therefore, W1 is equal to mg cos theta for a surface that is smooth, for a smooth surface. But if I have a rough surface, W1 will be equal to that's coefficient of friction, mg cos theta. So this is what we have. But then we'll try to resolve W2. Go the same way. W2 all over mg is equal to sine theta. You should not find, because this is adjacent, this is opposite. Opposite over hypotenuse. That's how we arrived here. So our W2 is equal to mg sine theta. Having said that, now we are asked to find the maximum frictional force that will keep the body in what? In equilibrium. Resolving this, you are told that this force is here. So for we to have a force that is acting upward in this direction, there must be another force that is acting in this direction in order for this body to be in equilibrium. And with what we've just done, we can see that that force is mg sine theta. So going by the same rule of Newton's third law of motion, or for anybody to be in equilibrium, that means the sum of all the forces acting on that body in that plane must be equal to 0. What are we saying? We are saying in essence that 420 Newton is equal to mg sine theta plus our frictional force. So with this, we can now confidently say that make F the frictional force the subject of formula. It becomes 420 Newton minus mg sine theta, which is 420 Newton minus 40 kg times 10 sine 30, which is 0.5. So at the end of the day, we are having 420 Newton minus half 20, that's 200 Newton, which is equal to 220 Newton. That is the maximum frictional force. So the maximum frictional force is 220 Newton. We are done. Now the next question we are asked is to look for the coefficient of friction. B, coefficient of friction is equal to F. Formula for coefficient is equal to F is equal to mu R. Therefore, our mu is equal to F all over R. And you and I know that the surface is a rough surface, so this is what we'll be using. This is what we'll be using. This will become 220 all over mg, 40 times 10 times cos 30, which is root 3/2, or we say 0.866. So we have 400 times 0.866. That's it. 220 divided by answer. We have 0.635. That's our coefficient of friction. So coefficient of friction is a ratio, so it does not have any unit. Is 0.635. That's our answer. So remember what I said. It's very important that you take note of some words, some English terms that must be translated into mathematical figures when you are solving physics. With that, I don't think that you have any problem solving solving problems with regard to physics. Bye. See you in our next class.